when there's a,
When what? No, violations to electron configurations take place when? You only have to remember.
In the transition mode.
Transition metals, you only have to remember that most of the exceptions or most of the differences in the periodic table occur for when you have a subshell that is half filled or completely filled. Okay. So when we are doing an electron configuration for something and it ends in this S2D4, okay? The D takes 10 electrons, right?
right,
It will not look like this because the D wants to be what? Half filled. So this is going to look like that. Okay? So whenever you do an electron configuration and it ends here, you are going to rewrite it as that. Okay? This doesn't happen all the time. It just happens most of the time. The ones that I can give you, since they're violation, I don't want you to memorize everything on the periodic table, so I just give you the ones that are violations. This is a violation. How about this one? Should that be another violation?
yes, sir.
That should be another violation because it ends in S2D9. You only know it after you do it, and you notice, okay, it wants to be full here, and this is supposed to be a 10, so it's going to change to S1D10. How simple is that? Hello? It's very simple. How do you do an electron configuration? By using what? The off-ball diagram, or you can also use a periodic table. Yes? We have done complete electron configuration, which is the one that you begin in 1s1, 1s2, like that. Now there is one called condensed electron configuration, and in which you put the noble gas configuration, and you put the noble gas inside of the brackets, and then you continue with whatever S and whatever P or whatever else you have. Okay? Yes or no?
Yes.
So let's do the periodic way of the electron configuration. Do you guys have a periodic table?
Yes.
If you don't have a periodic table, get one out. If you still don't have one, then Google one. So here's how it is. When we are doing the electron configuration from the periodic table, you're going to have here, these are what?
The quantum number.
Principal quantum number, or they are the periods in which the electrons are. How many periods in the periodic table? 7. Okay? So, in the periodic table, it looks like this, yes? This area here, where the first two groups are at, this is called the S area. Okay? Because the electron configuration will end in the S. This here will be the P area. The electron configuration for any of these elements here should end in P something. This here, from here to here, is the D area, and this here is the F area. Particularly your grade, yes? You will not forget that.
So fun.
Yes?
Yeah.
Now, the S elements, the elements that have S and P only, are called representative elements. The only reason why I'm telling you this now is because I'm going to say representative elements, blah, 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 and you need to know what they are. The D elements, or the elements that end in D, are called what?
Transition.
Transition metals. And the F elements are
Failing elements.
what?
No.
What did you say?
Failing elements.
Oh yeah, they are failing elements. They're called inner transition elements. we're not going to do any of the F elements, so I don't want you to have in your head about failing. So we're not gonna do intertransition, we're gonna do representative and transition. Okay? Now, if we're doing an electron configuration, and you encounter, let's say this is 1, this is 2, and this is 3 and 4 and 5, yes? If you are in the S area, the 1 is going to have the 1 and the S together. So this is in group 1, yes? Next to period 1. So this should be the 1S. And this is still in period 1. So this is going to be the 1S, still the 1S, but this one is going to have 2 electrons while this one has 1 electron. After we're done with the S, which can only fit 2, we're going to go to the 2p. Okay? Yes or no? Now, of course, this is not going to be like this, okay, because this is just the explanation. For the first one is hydrogen, and for hydrogen, it has 1 electron, yes? And that will be the 1s1. And then helium is here, yes? Helium is on this side, and helium would be 1s2. And then comes this second period here, so I should have done this before. Okay? But that's besides the point, it doesn't matter. So, what I wanted to explain from here is when we get to the D, it's not going to be 4D. It's going to be -1. So whenever you get to the period, you got to subtract 1, and that will give you the D. So if you are in period number 4, what would it be?
3D.
Would it be 4D? No, it would be 3D. If you are in period number 4, it would be 3D. But what are the S's for period 4? 4S. Okay? Because the 4, the S will have the same number, and the P will have the same number. So what is the P that belongs to period 4?
4P.
4P. So what is the D that belongs to period 4? 3D. So let's say I am in period 6. Give me the S's, the P's, and the D's for period 6. And the F's. So for period 6, what are the S's that I have? 6S. Okay, if I have 1 electron, it will be 6s1. If I have 2 electrons, it will be 6s2. This is for 1 electron. This is the first group. Ends in S1, and the second ends in S2. And when you get to the P, which is this area, the first P will be P1, and the second P2, P3, P4, P5, and P6. So this will be 6P, yes? And what else is going to be here?
5D.
5D, all right. And
4F.
4F. Because this is F, is -2. Yes or no? So when we look at a periodic table, we can do the condensed electron configuration and the complete electron configuration by looking at the periods in which they are and not using the off-ball diagram. Okay? Yes or no? So, let's do carbon. Okay? When we look at the periodic table, which one is the first element? Hydrogen. And because it is in what period is hydrogen in? 1. So I am going to write 1s, and hydrogen is 1, right?
Yep.
And then I go to helium. Helium is
1s2.
1s2. And I am done with period 1. I go to period 2. That's where carbon is. So what is the S for period 2?
2s2.
2s. And it has 1 and another electron, so that's 2s2. According to the off-ball principle, now I go to the next one. And period 2, what is the P for period 2?
2p.
2p, because it belongs to period 2 and it's the same number as the period.
2p.
And how many electrons am I going to have on this P?
2.
2 electrons. How many electrons in carbon? 6 electrons total. Yes or no?
Yes.
So that was the electron configuration for carbon. Let's say I wanted to do the condensed electron configuration for this. I would look at the previous period. And I would look at the noble gas in the previous period. Which one is the noble gas in the previous period?
Helium.
Helium. And I will write in parentheses, not in parentheses, what's this called?
Brackets.
Brackets.
Yes.
I would write in parentheses, yes?
Yes.
Brackets. You will write helium. And the electron configuration for helium is what from here? Is this, yeah? Yes?
Yes.
So that's helium, and then the rest,
2s2.
2s2,
2p2.
2p2. Okay? Which one do you like better? Condensed electron configuration or complete electron configuration? You are going to have all of them, unfortunately, on your test. I don't want you to think that, okay, what?
Outstanding.
Outstanding. Okay, why don't we do mo? You want to do mo? Which, do you know which element is mo?
Yeah.
Like mo money?
Millennium.
More money.
That's an exception.
Why you gotta mess things up, girl? I'm smack you.
It wasn't me.
Who said?
Someone in the back.
It doesn't matter, everything is gonna go to you now. This is mo. Okay? So, I want you to do the complete electron configuration for mo. And mo is what?
Molybdenum. Something like that.
Molybdenum?
Yeah.
Outstanding.
Professor, can we do the condensed one?
You are going to do complete,
Oh, complete.
condensed. You're gonna do them all, okay?
Yeah, okay.
Don't resist it, okay? You gotta relax so you enjoy this. Everybody has a periodic table, yes? I want everybody, you don't have a periodic table? I want you to look at the periodic table, please, and do it from the periodic table. What's taking so long?
It's the complete one.
Yeah. Complete one is long.
Is the what?
Complete one? That's from it.
The complete one is long?
Yeah.
42.
Is what?
It's like 42.
Really? It's a lot of electrons, huh? Mo. You. What's the name of this?
Millennium. Hyper. Right?
Hypo.
Hyper.
Fluoride. Is it single charge or a variable charge? Mo.
Single charge.
Mo is single charge. Is it in group 1? Why are you looking down? Not in group 1. Is it in group 2?
Yeah, no, it's very correct.
It's variable charge because it's not in group 1, it's not in group 2, it's not aluminum, gallium, zinc, cadmium, and silver.
I think it actually gets the exception here.
I don't know. Can't predict stuff like that ahead of time.
I think it ends 5S1 and 5D5.
Okay, guys, let's do it. Okay, you guys are taking too long. Like this, you are going to fail the exam. First one is
1s2.
1s2, and then 2s2, and
2p6.
2p6,
3s2.
and then we are in period number 3.
Yes.
Yes?
Yes.
In period number 3. In period number 3, the S that belongs to period number 3 is
2.
3s2. And then will we have a D? Do we have a D then?
No, not yet.
Not yet. So
3p6.
after the 3s comes
3p6.
3p6, and after the 3p6,
4s2.
That's 4s2.
3d10.
Where's- Mo is a group 5, or period 5.
if you ask me, the third period is supposed to have the S, then the P, and the D. Yes or no? No?
Period 4.
Because of the way the periodic table is?
Right, this one.
Maybe I should find a periodic table. Let's find it. There's one here. This is, you can't see it, but this here is 1.
S.
This here is 2. And this here is 3. So we are looking at MO. So here, this one is the what?
4s2.
1, 2, 3, and 4.
4s2.
So 4s2.
So 3s2, that's this one, right?
Yeah.
1, 2, 3. And then comes
3p6.
3p6. And after the 3p6 comes
4s2.
4s2. And after the 4s2 comes,
3d10.
it is in period 4, the first D, yes?
Yes.
But it's not 4D because it is -1, so it is
3d10.
3D what? 3D10 because we are not at Mo yet. 3D10, and then comes,
4p6.
this is in period 4, so 4p6,
6.
okay? And then,
5s2.
5s1.
This one and
5s1.
Oh,
No,
yeah,
no,
it's not complete.
no, not 5s1.
It's 5s2. We haven't gotten to Mo yet.
That's right, we have not gotten to Mo yet. So, this is 5s2.
And 4d4.
We don't plan ahead of time, yes?
4d4.
5s2, and then comes
4d4.
4,
4d.
because it is on
4D.
what period is this 4D?
5.
On the 5th.
In period 5. So 4D what?
4d4.
4. And now is when I notice that this could have one of these electrons promoted, yes?
Yes.
To a higher rank. One of these electrons go here so you can have a D5, yes? So this whole thing would change to S1, D5. And this is called a violation. Yes? To who? Violation to who? Who was violated here? Alpha principle. Okay, alpha principle says that you must fill this one before you fill the next one. So this is obviously a violation. Violations never occur for representative elements. Is that clear?
Yeah.
It only occurs for the D elements, okay? And not for even all of them, and there isn't a lot. Okay? Yes?
Yes.
How was that? That was good.
Outstanding.
Outstanding. Now, I'm going to show you something from here. Or not from here. Okay, why don't you do the electron configuration for, oh, let's do the condensed, yes?
Yes.
Okay. So, with your bionic eyes, yes? With your bionic eyes, MO is here. In the previous period, is period what? 1, 2, 3, and 4.
4.
And period 4, the noble gas at the end is
Krypton.
krypton. That's the element that gets Superman weak, right? Is it it? Is that one it?
Yes,
It's
Kryptonite.
kryptonite. It's like this element, but with green horns and stuff. So, krypton. And then what follows krypton is,
5s2.
you look here, you are doing it from the periodic table. 1, 2, 3, 4, and 5. So this is 5s,
2.
2, and then comes
4d4.
same thing.
And
4d4.
we can change it to again?
Now we have this problem, and we are going to say
1 and 5.
1 and 5 because this is
Violation.
violation. And you know this is a violation because if you can promote an electron to have this half filled, then it will. Okay? Why don't you do the one for copper?
See.
Cu. Don't do the whole thing, okay? That's too much work, okay? Just do
The
condensed.
condensed.
Condensed?
All right. I love condensed.
Oh, we all.
For copper, C.
So in what period is Cu in?
4.
Period 4. So what is the noble gas in what period?
Argon.
No.
Argon in period 3.
Period
What
three.
period is the previous noble gas to period
Oh,
4?
period three.
Period 3. The noble gas in period 3 is
Argon.
Ar, yes?
Yeah.
That's the noble gas. And then comes
Forest.
period 4,
Forest.
which is 4s
2.
2, and then
3D9.
3D9.
And same.
3d9.
But then you change it because it's a violation.
When we get here, we say, oh, okay, well, there is a possibility that this is not going to be a 9, yes?
Yeah.
Because it wants to be promoted, so this can have a completely filled D.
Yeah.
So, yes, that's what it does.
One then.
Professor, what if it's a 3D8 and it does
It
it?
depends on the element. Sometimes it promotes both of them,
Oh, okay, sometimes it doesn't.
and sometimes it doesn't. It depends.
Oh.
So I only teach you the ones that,
Are 9 and 4.
yes, 9 and 4 are the ones that I give you. Because the other one would require you to memorize the periodic table. You know, you could memorize the periodic table, but then I want you to know other stuff. So, did you find it, Mitch? It was locked? Oh. Sometimes they get married and they change their name.